Assalamu alaikum. My name is Abdullah Ajmal and today I will be performing lab number 6 of DLD, which is based on multiplexer and demultiplexer circuit. So what is a multiplexer? Multiplexer is a multi-input device that has only one output, and that one output is based upon a selector inputs that decide which of the input will be passed on to the output. So there are different type of multiplexer like 2-input multiplexer and 4-input multiplexer, in which 4 of the inputs depending upon this 2-bit selector which determines which of the output will appear on this OR gate, output of this OR gate. So basically what the exercise requires us to perform experimentation and Verilog code for demultiplexer circuit. So basically a demultiplexer circuit is inverse of multiplexer circuit. It has only one input, and based on the selection inputs it gives us many outputs. So there are also different types of demultiplexers. So the one we are going to discuss is 1 to 4 DEMUX or demultiplexer circuit. So this is a truth table, and these are the equations that will be used in Verilog coding, and this is a circuit that we have based on only logic gates. So now we will move towards the Verilog code. So as you can see, I have already written the Verilog code. So for the gate level implementation, so we are going to perform 4 different type of implementation. One is gate level implementation, the other is logic statement implementation, then there is assignment or assign level implementation, and the final is if else statement implementation. So let me rename. So basically what is happening in this code is that based on the diagram and the equation that are present here, we have simply written the equation or the Verilog code using the names of the gate like not gate, AND gate, AND gate, AND gate, and AND gate, because we have 4 different types of outputs. So we have 4 different AND gates with 3 inputs there. So they are 3 input AND gates, and the NOT gate, so we have used a wire for NOT gate so that the signal are converted to NOT form, and then the wire carries it to our further our circuit. So now we can view the article view of the circuit. So as you can see from the article view of the circuit, it is same as that one we have seen previously using AND gates and NOT gates. So this is a symbol of NOT gate that is used by using this wire. So now let us move on towards the university DWL program. So now basically what we have to do, this L is the input line which is always 1, so we will assign it 1. So S0 and S1 are the what they say are select lines, so we will make them in the form of a waveform so that they have interchanging inputs, so that we can get 0, 0, 0, 1, these types of inputs. Now we'll go to value, and then we overwrite clock, give it a period of 100, then we will go to S1 and increase its period to 200. Now if we run our circuit, So from this output we can see that whenever S1 and S2 both are 0, it means that in the bit form the output should be provided on the Y01. So we have high output on Y0. So when we have 1 on S0 and 0 on S2, so we have 10, which means that our second output Y2 should be high. So we can see that our second output Y is high, Y1 is high. Now we will move toward the third part, in which we can see S0 is 0 and S1 is high. So it means that we have 1 and 0, 10, which means that our second one should be on, Y2 should be. So our Y2 is on, sorry, in this part we have 0, 1. So it means that our Y1 should be on. So in this we can see our Y1 is on, in this we can see our Y2 is on. So for the final stage we have both high, 1 and 1, which means 3, so Y3 should give us the output. So similarly this waveform shows that which of the following output will give us, which of the following output will be functional when the following input is given. So this was the first part, which was using gate implementation. Now we will move on to the second part, which is the with logic statement. So the simple thing that the difference between the logic statement and the using logic gate implementation is that in logic gate implementation we directly use the gate names like AND or NOT and differently assigned wire. So in the logic statement when we can write the equations in terms of output, directly write the equations of the output in terms of equations like we have seen in there, like this. These equations are directly implemented in the circuit by using a sign statement. So it will also give us the same output. Now we can see its RTL view. So basically the RTL view of this circuit and the previous circuit should be same because we are using simply logic gates. Now we will also move towards this previous to BWF program. So now again we have to get this one we got the period of interest and the second one was 2. So it should have the same output as the first one. So this program is also set and it has also program similar to the previous one. So when both are 0, So y0 should be high, so y0 is high. When we have 0 which means 1, so y1 is high. Then we have 1 0 which means 2, so then our y2 is high. And finally we have both high, 1 and 1, which means y3 should be high, so y3 is high. Now let us move towards the third part. So the third part is basically based on so the third part is basically based on case level implementation. So let me copy them. I'll explain case level implementation. So there is not much difference between case level implementation and the other implementations. So in the case level implementation, we use the always statement. So always statement is basically like a bigger loop, or we can say a switch case, in which we can define our different cases upon which our output will be determined. So in here we have REG, which will store our output value so that they can be assigned in further in our cases. So the first case, the case is based on S0 and S1, which are inputs. So when our inputs are 0 and 0, so both are low, then our y0 should be should give the output and other should be 0. Then this case should so the syntax is that it should begin with begin and end with end. Then our second case starting with 0 1, so value is 1, so y1 should be high, another should be low. In the third case we have 1 0, which means 2, so our y2 should be high and other should 3 should be 0. And similarly in the last case our 3 should be high and other should be low. And for this we have to write default case, so we have written in default case that it should display to check the control bits. So similarly we have inputs S0 and S1, which are the control bits, and L is the direct input that will be coming in output depending upon what is our selection. So basically RTL of this circuit will be somewhat different than the gate level implementation and the logic implementation. Let us see the RTL different. So we can see these are the logical units to RTL for different applications. Now let us move to the university. So like the previous two cases, the output of this case is also same. So we can see when the both of the inputs are low, y 0 should give us the output, so it is high. Secondly, when it is 0 1, so our what does 0 1 means? 0 and 1. It means that our the second input should be 1 0. So what does 1 0 mean? That our second should be high, so our second is high. Then we have 0 1, which means our 1 should be high, so our y1 is high. And then we have 1 1, which means our 3 should be high, so our 3 is high, y3 is high. So now let us move towards the final part of this lab, which is using if-else statement. So basically if-else statement is also similar to the case statement, but the basic difference that we are using if-else and else-if statements. Basically there is no difference. Similarly we are using always select and R, and then we are performing the same things that we have performed in the previous circuit. The attribute is quite complex. Let us move towards the next video. Now we have to select values. So this is the final circuit of the lab. So as you can see, when we have 0 0, while when we have 10, our y2 is on, when we have 0 1, our y1 is on, and when we have 11, our y3 is on. So basically this is how DEMUX circuit is working. So basically in this lab we have covered 4 basic implementations of DEMUX. The first one is using the gate level implementation, the second is the statement implementation, the third is case statement implementation, and the fourth one is if-else statement implementation. So this is all from my side. Thank you for watching.